to Valarmathi'S classes. In the previous video, we have seen some topics under the main topic sequences. Now in this video, we are going to see the first type in the special types of sequences. Okay, the first type is arithmetic sequence. Already we have seen about sequences. In a sequence, there will be some values arranged in some order. For example, so we are having 4 values arranged in order. The first value is 1 and the next it is 2 and the next 3 and the next it is 4, and we have seen already each value or each element, it is also called as a term. So we are having 4 terms here. So we have to use curly brackets on either sides of the values. All these things and all we have seen in the previous video. So if needed, you can refer the previous video and then come to this video so that it will be easy to understand. Okay, so coming to arithmetic sequence, it is a sequence where the difference between two consecutive terms is a constant. So consecutive means one term and the next term. So for example, if we consider this sequence 1, 2, 3 and 4 are the terms. So here this is the first term, second term, third and fourth. So now when we subtract this first term from the second term, it becomes 2 minus 1. So it is equal to 1. That is, the difference between these two terms is 1. Now when we consider these two terms, they are the next terms. So both can be named as consecutive terms. So the difference between these two consecutive terms is 1. Now coming to the second and third, these both terms are consecutive terms. Now the difference between these two terms is, it is 3 minus 2, so it is equal to 1. So here we are having the same difference as the first one. Coming to the third and the fourth term, the difference is 4 minus 3. So it is equal to 1. So we are having the same difference. So 1 and 2, they are consecutive terms. The difference between both the terms is 1. And 2 and 3, here they both are consecutive terms and their difference is also 1. And coming to the third term and the fourth term, their difference is also 1. That means when we consider any set of consecutive terms, the difference is the same. That is, we are having the same difference as 1. That means the difference is a constant value. It is equal to 1. So when we have such a type of sequence, we can name that sequence as arithmetic sequence. So arithmetic sequence is a sequence where the difference between the consecutive terms is a constant. Constant means the same value for all the cases. Let us consider one more example. 2, 4, 6 and 8. So here this is the first term, second, third and fourth. Now these both are consecutive terms, these both are consecutive terms and these both are consecutive terms. So now the difference between the first term and the second term, it is equal to, since it is larger, 4 minus 2, so it is equal to 2. So similarly here the difference is 2. Similarly here the difference is 2. So the difference between the consecutive terms, it is 2 always. That means the value is a constant. It is equal to 2. So this sequence can be named as an arithmetic sequence. Now if we consider this sequence, here it is 1, 2 and 4. So 1 and 2 they are consecutive terms and 2 and 4 they are consecutive terms. Now here the difference between the first and the second term is 2 minus 1, so it is equal to 1. Coming to the second and third, the difference is 4 minus 2, so it is 2. So here the difference value is 1 and here the difference value is 2. Both vary. So it means that difference between the consecutive terms are not the same value. That is, it is not a constant. So this sequence cannot be called as an arithmetic sequence. So it is not an arithmetic sequence. So a sequence is an arithmetic sequence only when the difference between the consecutive terms is a constant. Okay, now here this one, it is the difference between the consecutive terms and also it is a constant value. So it is a common value. So that difference value can be called as common difference. Common difference, and it is denoted by the letter D. So this difference, it is called common difference and it is denoted by the letter D. Okay, so now the next we can see how to write down the general form for an arithmetic sequence. So for reference, let us consider the same sequence of values 1, 2, 3 and 4. Okay, so already we have seen the common difference, it is denoted by the letter D. So now the next, let us use the letter A to represent the first term present in the sequence. So here the value of A, it is equal to 1 because in the sequence this is the first term, the value is 1. So A, it is equal to 1 for this sequence. So now we can bring out the general form for the arithmetic sequence in terms of these parameters. I am going to write down the general form for an arithmetic sequence. So we have to use curly brackets on either sides and we have to write down the expressions for the terms present separated by commas. Okay, so now here we have considered the first term as A. So we can write down A at the first place. And the next we have to use a comma. We have seen all these concepts in the previous video itself. And the next we have to find out the expression for the second term. So now let us consider this example. Here this is the first term and this is the second term. Now we have to bring out an expression to represent this second term. So we have only two parameters. One is D, that is a common difference, and the next one is the expression for the first term, that is A. So in terms of these parameters, we have to bring out an expression for the second term, and that we have to write here. Okay, so now actually what has happened, the difference between these two consecutive terms is 1. It means that when we add this 1 to the first term, we will get the second term. So now this 1 is nothing but the common difference and we have the representation for the common difference as D. So when we are going to add this common difference to the first term, so first term already we have represented as A. So when we are going to add this difference D to the first term, that is A, we will get the second term. So the second term becomes A plus D. That is A, it is the first term. When we are going to add the difference to the first term, we will get the second term. This is a difference value. When we add this 1 to the first term, we will get the second term. So now we have got the representation or the expression for the second term. Now in a similar way, we have to find out the expression for the third term. Okay, so now coming to the third term, here the third term minus the second term, it is equal to 1 and that is the difference. Of course, since it is an arithmetic sequence, we will be having all the difference values the same. So it will be definitely equal to 1. Okay, so now when we add this 1 to the second term, we will get the third term. This 1 is nothing but the common difference and this second term already we have found out and we have written as equal to A plus D. So when we add the difference value to the second term, we will get the third term. So now difference value is nothing but D when we add that to the second term. Already we have the second term equal to A plus D. So when we add these both, we will get the third term. So it becomes A plus D plus D, it is 2D. So now the third term becomes A plus 2D. Okay, now in the similar way we can find out the fourth term. So here the difference, it is equal to 1. So when we add this difference value to the third, we will get the fourth term. So now the fourth term becomes third plus D. So third it is A plus 2D. So A plus 2D plus D. So it becomes A plus 3D. So now this is the fourth term. Now when we are writing down the general form for an arithmetic sequence, we can use dots here So already we have seen about finite sequence as well as infinite sequence. Coming to finite sequence, there will be an end to the sequence and will not be using dots there. And coming to infinite sequence, there will be no end to the sequence. Already we have seen this in detail. So in order to show that it is an infinite sequence, we will be using dots. So now here, since it is a general form for an arithmetic sequence, we can use dots here because we do not know what will be the end for the sequence. So now here when we are finding out the difference, it is a plus b minus a. So a minus a, it becomes 0. So the remaining, it will be equal to d. So the difference between these two terms is d. Coming to the second and third, a plus 2d minus this term. So here since we are having minus, it becomes minus. We have to open a bracket. It becomes minus a plus b. So it is equal to a plus 2d minus a minus d. So a minus a, it becomes 0. Will get cancelled. 2d minus d, so it is equal to d. So now the difference between these two terms, it is d. Similarly, when we find out the difference between these two terms, we will get the same d. So this goes on. So now this is the general form for an arithmetic sequence. Now the next we can see what is the general expression for the terms present in the arithmetic sequence. Okay, so already we have seen in the previous video, when we consider a general sequence, the expression for the terms we have considered as xn. So when we come to the first term, if suppose we are having this sequence, so here it is the first term. For first term, this value of n, it is equal to 1. We have seen this in detail in the previous video. So for the first term, the value of n is equal to 1. So the term becomes x1. And coming to the second, the term becomes x2. So x1 is equal to 1, x2 is equal to 2, x3 is equal to 3 and x4 is equal to 4. We have seen all this in the previous video. Now similarly here, we have to write down the expression for the terms. So we can use the same representation here. Let xn represent the terms present in the given arithmetic sequence. So now this xn is equal to a plus d into n minus 1. Here this represents the terms. This a represents the first term. Already we have seen. This d represents a common difference. This n represents the position of the terms. So for the first term, the value of n will be equal to 1. So now this becomes the expression for the terms present in the given arithmetic sequence. That is, for the first term, the value of n, it is equal to 1. So the term becomes xn. So it is equal to x1. It is equal to a, it is the first term, plus d, it is the difference, and this value of n, it is equal to 1. So it becomes 1 minus 1. So it is equal to a plus d into 1 minus 1, it is 0. So it is equal to a plus 0. So it is equal to a. So the first term x1, it is equal to a. So we have obtained. That is, already we have brought out the general form for the sequence. So here we will be having a as the first term, a plus b as the second term, a plus 2d as the third term, and this will be going on. So now this is the general form for an arithmetic sequence. Already we have seen. So the first term, it is equal to a. So here when we substitute the value of n as 1 for the first term, it becomes 1 minus 1. So it will be equal to 0. So this term, it will get cancelled. So we will be getting the term as a. So we have got. So it is for this reason that we have used this n minus 1 here. Okay, now coming to the second case, for n is equal to 2. That is, for the second term, the value of xn, it is equal to x2. So it is equal to a plus d into the value of n, here it becomes equal to 2. So 2 minus 1. So it is equal to a plus d into 2 minus 1, it is equal to 1. So it is equal to a plus d. So we have got the second term. Similarly, for n is equal to 3, if we do in the same way, we will get the value of x3, it is equal to a plus 2d. Since here the value of n is equal to 3, it will be 3 minus 1, so we will be getting 2, so 2d. Okay, so in order to bring this variation only, we have used this n minus 1 here. Similarly, we can find out the value of x4 also. It will be equal to a plus 3d, and this goes on. In this way, we can find out the expression for any term. So now this is the general expression for the terms present in the arithmetic sequence. So now by using this expression, we can bring out the answer for many types of questions. So we can see some examples. Okay, so now let us see this problem. So here it is given, find the 10th term of the sequence 4, 9, 14, 19, etc. Okay, so the first thing we have to do is we have to check whether the given sequence is an arithmetic sequence. Only then we can use the formulas corresponding to the arithmetic sequence. Okay, we have to find out the difference between the consecutive terms. So here the difference between these two terms is 9 minus 4. So it is equal to 5. And 14 minus 9. So it is also 5. Here also we are having the difference as 5. So all the values are the same. So the common difference value, it is a constant, and also it is equal to 5. So this becomes an arithmetic sequence. So we can use the formulas corresponding to the arithmetic sequence itself. Okay, so now we are asked to find out the 10th term for the sequence. So first we have to write down the general expression for the terms present in the sequence. Here, since it is asked the 10th term to be found. So the expression for the terms present in the sequence is xn is equal to a plus d into n minus 1. Just now we have seen this. Okay, so here a it is the first term, d it is a common difference value, n it is the position of the terms present in the sequence. This xn represents the term. Okay, so now first we can write down what is the value of a and d. Okay, so now this is a given sequence. The value of a it is equal to 4. Since a it is nothing but the first term, here the first term it is equal to 4. So the value of a it is equal to 4. Now coming to the common difference d, it is equal to 5. Already we have found out. So 9 minus 4 it is 5, 14 minus 9 it is 5, 19 minus 14 it is 5. So it will be 5 continuously till the end. So now the value of d it is equal to 5. Now the next we are asked to find out the 10th term. So that is the value at the 10th place. So that is nothing but the position of the term. So the value of n it is equal to 10. It is given here. So now the value of n it is equal to 10. We have got the value of n also since the 10th term is asked. So now by using these values we can find out the required term. Okay, so now what we have to find out is x10, 10th term. xn represents a term. It is the expression for the term present in the sequence. We are asked to find out the 10th term. So we have to find out x10. So now x10 is equal to a plus b into n minus 1. The value of a it is 4. So 4 plus the value of d it is 5. 5 into the value of n it is 10. 10 minus 1. So it becomes 4 plus 5 into 9. So it is equal to 4 plus 45. So it is equal to 49. So now this is the required answer. That is the 10th term of this sequence is 49. So in this way, if any sequence is given and if you are asked to find out any term in that given sequence, we can easily find out using this formula. But the only thing is, first we have to confirm whether that given sequence is an arithmetic sequence or not. We have to check it. If it is an arithmetic sequence, then we can use this formula and we can bring out the term which is required. Okay, now if the question is find the arithmetic sequence with 4 as the first term and 5 as the common difference. So the first term it is equal to 4. So already we know the representation for the first term, it is a. So it is equal to 4 and the common difference it is given as 5. So d it is equal to 5. So now we have to find out the sequence. So here we can bring out the answer for this question in two ways. The first one is, already we have seen the general form for an arithmetic sequence using the parameters a and b. That is, the general form is a plus b, a plus 2d, and etc. So here we are having the values for a and d. So we can use these values here and we can bring out the sequence directly. So in this way also we can solve. So first we can solve by using this method. Here the first term becomes, here it is a. The value of a, it is 4. So we have to write down 4 here. Now then, comma, and the second term it is a plus b. So it is 4 plus 5. So it becomes 9. Then, comma, the third term becomes a plus 2d. So a, it is 4. So 4 plus 2 into 5. 2 into d. So 2 into 5. So it becomes 4 plus 10. So it is equal to 14. So the third term becomes 14. And the next, you can use etc. Okay, so now this is the required sequence. This is one way. The other way is, we know the expression for the terms present in the arithmetic sequence. Already we have seen the formula. It is xn is equal to a plus d into n minus 1. So now we can find out what is the first term by substituting the value of n is equal to 1. So it becomes x1 is equal to, here the value of a, it is 4. 4 plus, and here the value of d, it is 5. So 5 into the value of n, it is 1. So 1 minus 1. So it is equal to 4 plus 5 into 0. So it becomes 4. Now the second term is, for the second term the value of n, it is equal to 2. So it becomes x2 is equal to 4 plus a plus d into n minus 1. So the value of d, it is 5. So 5 into the value of n, it is 2. So 2 minus 1. So it is equal to 4 plus 5 into 2 minus 1, it is 1. So 5 into 1, so it is 5. So 4 plus 5, it is 9. And the next, the third term, it is x3. It is equal to a plus, so a is 4 plus d into, so 5 into, here the value of n is 3. So 3 minus 1. So it is equal to 4 plus 5 into 3 minus 1, it is 2. So it is equal to 4 plus 10. So it is equal to 14. Similarly, we can find out x4. So in this way. So now here we have got the terms. The first term it is 4, second term it is 9, third term it is 14, fourth, fifth we can find out. Okay, so now by using all these terms we can bring out the sequence. So the sequence, it is equal to, first we have to write down the first term. So it is 4, then use a comma, and the next, the second term it is 9, and the next, the third term it is 14, and the next. So now this becomes the sequence. Since here there is no condition given about the total number of terms, we have to consider it as an infinite sequence only. So I have used dots here. Okay, so now this required sequence is 4, 9, 14, etc. So now in this way also we have obtained the same answer. So we can go by any way. Okay, so in this way, if the first term as well as the common difference is given, we can easily find out the arithmetic sequence. Okay, so let us see this problem. So here it is, find the value of n for a term equal to 69 in the arithmetic sequence 4, 9, 14, 19, etc. Okay, so here we are asked to find out the value of n. It is given the term, it is equal to 69. We are asked to find out the value for n corresponding to the term equal to 69. That is, we have to find out at which position we are going to have this term 69 in this sequence. So that is the question. So now here we are having the value of the term. So we know an expression for the term in terms of all the other parameters a, d, n and all. So now we can use that expression here. So it is xn is equal to a plus d into n minus 1. So now here this xn 4. And the next D, it is the difference. So difference, it is equal to 9 minus 4, here it is 5. So similarly we will be getting 5 in all the cases. The same example only I have considered. Here it is given arithmetic sequence. So there is no need to check also. So directly we can go by this way itself. Okay, so now the value of D, it is equal to 5. Okay, so here it becomes 4 plus, in the place of D we have to substitute 5. So 5 into n we have to find out. So n minus 1. Okay, so now here it becomes 69 is equal to 4 plus 5 into n minus 1. So it becomes 4 plus 5 into n minus 1. We can expand. So it becomes 5n minus 5. 5 into minus 1. 5. So now 69 is equal to, so here we are having constants 4 minus 5. So it is minus 1. Then plus 5n. So here we are having the variable which is to be found out. That is, we have to find out the value of n. So that we can have separately. So now let us consider this 5n here. Then this minus 1, it is a constant. So that can be taken to the other side along with this constant. So here it becomes 69. This minus 1, when it comes to the other side, it becomes plus 1. So it is equal to 5n. So 69 plus 1, it is 70. 70 is equal to 5n. Now in the next step, this n is equal to 70. Here we have a multiplication sign. So into sign. So 70. Here this into 5, when it comes to the other side, it becomes divided by 5. So now 70 divided by 5, it is equal to 14. So now the value of n, it is equal to 14. So now we have found out the answer. Find the value of n for which the term is equal to 69 in the arithmetic sequence this. So at the 14th place, we will be having this term 69. That is the meaning. So this is our required answer. The value of n is equal to 14. Okay, so in this way, if the term is given and if the value for A and D it is available, then easily we can find out the value of n using this method. Okay, now the next you can see this example. So here it is, find out the first term of an arithmetic sequence that has its fifth term as 24 and the common difference as 5. So here we are asked to find out the first term. First term, it is nothing but A. So A, it is asked, we have to find out. And fifth term, it is equal to 24. It means x5 is equal to 24. And the next, the common difference, it is equal to 5. So D, it is equal to 5. So x5, that is a term, it is known, it is equal to 24 and the value of common difference D, it is 5 and we are asked to find out the value of A. Okay. So here since we have the value of x5, that is a term, so we can use the formula for the term or we can use the expression for the term. So the expression for the term present in the arithmetic sequences, xn is equal to A plus D into n minus 1. So here in the place of n we have 5. So x5 is equal to the value of A we have to find out. We don't know that. So let us write it as A itself plus the value of D, it is available, it is 5 and the value of n, it is available, it is 5 minus 1. So now this is x5. Already it is given the value of x5 is equal to 24. So now this, it should be equal to 24. Okay, so now we can consider this section alone and we can proceed. Here A is the only unknown value and all the other values are constant. So we can proceed, we can solve and we can bring out the value for A. So it becomes A plus, here 5 into 5 minus 1, it is 4. So it is equal to 24. Now it is A plus 20 is equal to 24. Now the next it is A is equal to 24. This plus 20, when it goes to the other side, it becomes minus 20 and so it is equal to 4. So now the value of A, it is equal to 4. A, it is the first term. Already we know that A is the first term. I have considered the same example for all the cases. Okay, so the value of A, it is 4. So this is the required thing. So it is asked to find out the first term of an arithmetic sequence. First term, it is A. So we have got the value for A. So in this way, if a particular term is given and if we have the value of n as well as b, we can easily find out the value for a. Similarly, if the value of the term and the value of a and also the value of n is given, we can easily find out the value of d by using the same formula itself. In this way, we can use this formula to bring out many parameters. Okay, so this is about arithmetic sequences. Thanks for watching this video. We'll see the continuation in the next video.